The night sky has always whispered secrets, but in October 2017 it screamed something entirely new. A faint streak of light, caught by the Pan-STARRS telescope in Hawaii, wasn't just another comet or asteroid drifting through our cosmic neighborhood. It was something else, something that didn't belong. Astronomers named it Oumuamua, a Hawaiian word meaning scout or messenger from afar. But this messenger wasn't just passing through. It was a riddle wrapped in starlight, a tumbling enigma that defied every rule we thought we knew about the universe. Its strange shape, its impossible speed, its eerie acceleration as it fled our sun without a trace of a tail. It was as if Oumuamua was daring us to chase it, to unravel what it hid inside. What if this wasn't just a rock, not just a chunk of ice, but something carrying a secret so profound it could rewrite our place in the cosmos? What if Oumuamua wasn't empty at all? Imagine the moment of discovery. Astronomers hunched over screens, their breath catching as the data poured in. This thing was moving too fast, faster than anything bound to our solar system could. It wasn't orbiting the sun like a well-behaved asteroid or comet. It was an interstellar interloper, a wanderer from another star, the first of its kind we'd ever seen. Its trajectory was a sharp, fleeting arc, as if it had slipped into our system by accident, only to sling itself back into the void. But it wasn't just its path that set hearts racing. Oumuamua tumbled through space in a chaotic dance, spinning in ways no ordinary space rock should. Its brightness flickered wildly, dimming and flaring by a factor of 10, suggesting a shape so bizarre, either a cigar stretched impossibly long or a pancake flattened to an absurd degree, that it looked like nothing we'd ever catalogued. And then, the kicker. As it sped away from the sun, it accelerated. Not just coasted, not just fell under gravity's pull, but sped up, as if something inside was pushing it, something invisible, something alive. The scientific world buzzed with questions. But one voice cut through the noise. Harvard astrophysicist Avi Loeb, a man unafraid to ask the unthinkable, stood up and said what others only whispered. What if Oumuamua wasn't natural at all? What if it was a piece of technology, a relic from a civilization far beyond our own, propelled by the gentle shove of starlight? His words sent shockwaves through the community, not because they were reckless, but because they fit. Oumuamua's acceleration matched the physics of a light sail, a thin, reflective sheet that catches radiation, like wind in a sail. No visible jets of gas, no dusty comet tail, just pure silent thrust. Loeb pointed to its shape, its motion, its defiance of every known category of space object. He even suggested that fragments of a 2014 meteor recovered from the ocean floor might hold clues to extraterrestrial origins, tiny pieces of something not born in our solar system. The idea was bold, almost too bold, but it forced everyone to look closer. And the closer they looked, the stranger it got. What could be inside this cosmic drifter? Scientists began to peel back the layers, not with their hands, but with equations, telescopes, and imagination. One theory emerged from the shadows of quantum physics. What if Oumuamua's core wasn't made of ordinary rock or ice, but something exotic, something we've never seen? Researchers proposed an ultra-dense core, perhaps laced with dark matter or a hypercomposite material unknown to our periodic table. Neutrino telescopes, like the ice cube array buried deep in Antarctic ice, had been picking up ghostly signals. Faint neutrino shadows were these elusive particles, capable of passing through entire planets, seemed to vanish. Could Oumuamua's passage have left a trace in those detectors? A hint that its interior was interacting with the universe's fundamental particles in ways we couldn't explain? The thought was dizzying. A course so strange it could bend the rules of matter itself, a messenger carrying the chemistry of another star system. But the mystery didn't stop there. A joint NASA-ESA team fed Oumuamua's data into cutting-edge artificial intelligence, trained to spot patterns no human eye could catch. The results were staggering. The AI flagged the object's tumbling as eerily similar to a spin-stabilized probe, the kind we launch into space with carefully balanced mass to keep it steady. Its acceleration, its rotation, its precise distribution of weight. It all screamed engineered. Not a random rock, not a haphazard comet, but something with a structure, a purpose. The AI didn't care about human biases or the fear of sounding outlandish. It just read the physics and whispered, "This looks designed." Suddenly, the question wasn't just what was inside Oumuamua, but whether that what was meant to be there. Picture it, a silent traveler, forged in the fires of a distant star or perhaps crafted by hands we'll never know, tumbling through the endless dark. It passes our sun, feels the warmth, and something inside awakens. Not with a roar or a flash, but with a subtle push, a nudge that sends it speeding away, leaving us with nothing but questions. Was it a natural wonder, a cosmic accident sculpted by eons of radiation and cold? Or was it something more? A beacon, a probe, a fragment of a story we're not yet ready to read. The data kept coming, each piece more tantalizing than the last. Gravitational lensing, that cosmic trick where mass bends light, revealed tiny distortions in the starlight behind Oumuamua, suggesting pockets of dense material inside, like chambers or cores. Magnetometers on Earth twitched with faint anomalies as it passed, hinting at ferromagnetic materials, perhaps remnants of a planetary core from another world. And then there were the radio signals, ultra-low frequency whispers, not random noise but structured, complex, like the hum of something alive, or at least responsive. As the months turned to years, Oumuamua slipped beyond our reach, too far for our telescopes to chase. But its shadow lingered, a puzzle that refused to be solved. The hydrogen iceberg hypothesis offered a natural explanation. Maybe it was a frozen chunk of molecular hydrogen, so cold it could only form in the darkest corners of the galaxy. As it neared our sun, that ice could have sublimated, turning to gas and giving it that mysterious push, all without a visible tail. Or perhaps it was a nitrogen ice fragment, chipped from a Pluto-like world, its reflective surface and sublimating layers explaining its brightness and speed. These ideas were elegant, grounded in physics we could test, but they still painted Oumuamua as something extraordinary, a solid, complex object, not a hollow shell, but a layered marvel with secrets locked inside. Every theory, from the cautious to the audacious, agreed on one thing. Oumuamua wasn't empty. Its interior held something, whether exotic ice, crystalline structures, or even the faint possibility of technology that made it unlike anything in our solar system. It was a messenger, not just of matter, but of possibility. It forced us to confront how little we know about the universe beyond our tiny blue dot. As we stood on the edge of 2025, with new telescopes coming online and AI reshaping how we see the stars, Oumuamua's fleeting visit felt like a wake-up call. The universe was watching us, waiting for us to catch up. What else was out there, tumbling through the dark, carrying secrets we're only beginning to imagine? The stars have always been storytellers, but Oumuamua's tale was unlike any we'd ever heard. It wasn't just a visitor from another star system. It was a challenge, a cosmic gauntlet thrown at our feet. By 2025, the questions it left behind had grown louder, more urgent. What was inside this strange, tumbling object that danced through our solar system in 2017? Why did it behave like nothing we'd ever seen? Scientists, dreamers, and skeptics alike were haunted by the same thought. Oumuamua wasn't just a rock or a comet. It was something more, something with a heart, maybe not alive, but pulsing with secrets. As new data trickled in, from gravitational whispers to faint radio hums, the mystery deepened. Each clue painted a picture of an object not empty, but brimming with complexity, perhaps even purpose. And as we chased those clues, we began to wonder, was Oumuamua a natural marvel, or a message from a universe far vaster than we dared imagine? The first hint of its inner life came from its motion. Oumuamua didn't just drift. It tumbled with a wild, almost deliberate grace. Its rotation, clocked at roughly 7.3 hours, wasn't a simple spin like a top, but a chaotic somersault, as if it had been flung into space with a purpose that broke its balance. This tumbling caused its brightness to surge and fade, like a lighthouse beam sweeping across the void. To astronomers, this was a neon sign pointing to its shape, either a cigar stretched 10 times longer than wide, or a pancake so flat it defied nature's usual sculpting. Either way, it was alien in form, unlike any asteroid or comet in our solar system. But what held it together? A loose pile of rubble would have shattered under such violent rotation. Oumuamua's stability screamed of internal strength, a solid core or framework that could withstand the centrifugal forces tearing at it. Whatever was inside, it wasn't fragile. It was built to endure. Then there was the acceleration, the detail that turned heads and sparked arguments in lecture halls and online forums. As Oumuamua swung past the sun, it didn't just coast outward as gravity dictated. It sped up, as if something gave it a gentle shove. Comets do this sometimes, spewing gas and dust as their ices vaporize. But Oumuamua showed no such tail, no coma, no trace of outgassing. It was as if the thrust came from within, silent and invisible. One theory, elegant in its simplicity, suggested it was a hydrogen iceberg, a frozen slab of molecular hydrogen, so cold it could only form in the galaxy's darkest nurseries. As it neared our sun, this ice could have sublimated, turning to gas, and jetting out in streams too faint for our telescopes to catch. The idea was mesmerizing. A chunk of the universe's deepest freeze, carrying a propellant baked into its core, pushing it forward like a natural rocket. But even this explanation demanded a complex interior, layers of exotic material reacting to the sun's warmth in ways we'd never seen. Another possibility emerged, equally captivating. What if Oumuamua was a fragment of a Pluto-like world, its surface glazed with nitrogen ice? Researchers imagined it as a shard, chipped from an exoplanet, its reflective sheen explaining its brightness, its sublimating nitrogen layers driving that mysterious acceleration. Picture it, a piece of another world, sculpted by cosmic collisions, drifting for eons until it stumbled into our system. As the sun's heat peeled away its outer layers, it flattened, like a bar of soap worn thin, its shape shifting to match the pancake or cigar we observed. This model didn't just explain Oumuamua's behavior, it gave it a backstory, a life born in the chaos of a distant star system. Its interior wasn't hollow, it was a geological record, a layered archive of materials forged far from our sun. But the data kept whispering stranger things. Gravitational lensing, that subtle bending of starlight by mass, offered a glimpse inside. As Oumuamua passed through our system, the light from background stars flickered in ways that didn't add up. The distortions weren't uniform, as they would be for a simple rock. Instead, they suggested pockets of denser material, nodes, chambers, or cores, scattered within its body. It was like a cosmic CT scan, revealing a structure far from random. These findings weren't guesses. They were rooted in Einstein's relativity, in the hard math of how mass warps spacetime. Whatever Oumuamua was, it wasn't a uniform slab. Its interior was a mosaic, a puzzle of varying density that hinted at something intricate, perhaps even deliberate. Then came the magnetic anomalies. As Oumuamua traced its arc through our system, Earth's magnetometers, sensitive instruments tracking the planet's magnetic field, picked up faint, unexplained fluctuations. These weren't the usual ripples of solar wind or terrestrial noise. They were distinct, tied to Oumuamua's path. One hypothesis pointed to ferromagnetic materials inside, perhaps iron-rich remnants of a planetary core from its home system. On Earth, our molten iron core generates a protective magnetic field. Could Oumuamua carry a similar signature? A fossilized piece of another world's heart? The idea was breathtaking. Not just a rock, but a fragment of a planet, its magnetic memory preserved across light years. This wasn't an empty shell. It was a time capsule, holding clues to how worlds form beyond our reach. And then, there were the radio signals, the faintest and most tantalizing of all. Major telescopes, scanning the spectrum as Oumuamua passed, caught ultra-low-frequency emissions, whispers in the dark, neither random noise nor clear beacons. They were complex, structured, like the hum of a distant machine or the echo of something reacting to its environment. One theory suggested these signals came from layered materials inside, dielectric stacks that oscillated under solar radiation, generating electromagnetic fields like a natural crystal radio. Another dared to wonder if they were leakage, passive signatures of something designed to interact with starlight. Scientists split down the middle. Some saw a quirky but natural phenomenon, others a hint of something more. Either way, these whispers added another layer to the mystery, proof that Oumuamua's interior was alive with activity, even if only in the language of physics. As these clues piled up, another idea surfaced, one that pushed the boundaries of imagination. What if Oumuamua's interior wasn't just complex but functional? Researchers drew on cutting-edge materials, science pointing to photonic metamaterials, crystalline structures that bend light and radiation in unnatural ways. On Earth, we're building these materials to cloak objects or channel energy. Could Oumuamua harbor something similar, a natural or engineered lattice that captured solar radiation to steer or power itself? Its tumbling motion and acceleration made sense if it was designed to maximize exposure to starlight, its internal geometry converting that energy into thrust. This wasn't science fiction, it was physics we're only beginning to grasp. The thought was electrifying. An object, whether crafted or carved by cosmic forces, behaving like a passive spacecraft, its interior a symphony of light and matter. Every piece of evidence, from the gravitational lensing to the radio hums, pointed to the same truth. Oumuamua wasn't empty. Its interior was a labyrinth of materials, structures, and forces, whether shaped by nature's hand or something else. It challenged us to rethink what interstellar objects could be. Was it a geological relic, a frozen fossil from a distant star? Or was it a probe, a scout sent to brush past our sun and report back to the void? As we stood on the cusp of new discoveries in 2025, with AI and telescopes peeling back the universe's secrets, Oumuamua's fleeting visit felt like a spark. It ignited our curiosity, our fear, our hope. What other messengers were out there carrying stories we're only beginning to hear? Oumuamua was gone, a fleeting shadow lost to the infinite dark by 2025. But its story clung to us like stardust. It had swept through our solar system in 2017, a stranger from another star, and left behind a trail of questions that burned brighter with each passing year. Was it a cosmic accident, a chunk of exotic ice or rock sculpted by the universe's relentless hand? Or was it something more, a crafted thing, a messenger with a purpose we couldn't yet grasp? Every clue, from its eerie acceleration to its faint radio whispers, pointed to an object brimming with secrets. Its interior wasn't empty. It was a vault of mysteries, each layer peeling back to reveal a universe far stranger than we'd dared to dream. As we stood on the edge of new frontiers, with telescopes piercing deeper into the void, Oumuamua's visit felt like a call, a reminder that the stars were full of stories, and we'd only just begun to listen. The deeper we dug, the more Oumuamua seemed to taunt us with possibilities. One of the most striking theories came from the world of fusion physics, a realm where the impossible was starting to feel real. Scientists at places like NASA's Glenn Research Center had been experimenting with lattice confinement fusion, tiny reactions sparked when hydrogen is trapped in metal structures like palladium or nickel. Under the right conditions, cosmic rays could trigger microbursts of energy, small but powerful enough to nudge an object forward. Now imagine Oumuamua, its interior laced with hydrogen-rich crystals, drifting through interstellar space for eons. Cosmic rays, abundant in the galaxy's vast emptiness, could have ignited these microfusion events, each one a silent pulse of thrust. No visible exhaust, no comet-like tail, just a steady, invisible push that explained its sudden sprint away from our sun. The idea was thrilling, a natural reactor, not a machine, but a structure so finely tuned it mimicked one. Oumuamua's heart wasn't empty. It was alive with the universe's own fire. But what if its interior wasn't just reactive, but responsive? Another hypothesis leaned on the cutting edge of material science, where researchers on Earth were crafting photonic metamaterials, crystals that could bend light, channel radiation, or even cloak objects from view. What if Oumuamua's tumbling, its strange shape, was no accident? Its elongated or flattened form could have been designed, by nature or otherwise, to catch starlight like a sail, its internal lattices converting that energy into motion. Picture it, an object gliding through space, its crystalline core humming as it soaked up radiation, redirecting it to steer or accelerate. No electronics, no moving parts, just a passive system, elegant and eternal, responding to the cosmos like a leaf on the wind. This wasn't a hollow rock. It was a symphony of matter and light. A structure so sophisticated, it blurred the line between natural and engineered. The evidence kept mounting, each piece a brushstroke in a portrait of complexity. Gravitational lensing data, those subtle bends in starlight, had revealed density variations inside Oumuamua, pockets of heavier material, like cores or chambers, that no simple asteroid could explain. Magnetic anomalies, faint twitches in Earth's field as it passed, suggested ferromagnetic remnants, perhaps the iron heart of a shattered planet. And those ultra-low-frequency radio signals, caught by telescopes scanning its path, weren't just noise. They had structure, complexity, like the echo of something interacting with the solar wind or starlight. Some scientists saw natural oscillations, layers of materials vibrating under radiation. Others wondered if they were traces of something deliberate. A passive beacon, not shouting but whispering, waiting for someone to hear. Whatever they were, they confirmed Oumuamua's interior was dynamic, a place where physics played out in ways we were only beginning to understand. One of the most elegant explanations came in 2023, when researchers proposed Oumuamua as a water ice comet transformed by its long journey. Cosmic rays, bombarding it for millions of years, could have split its ice into molecular hydrogen, trapping it within the solid matrix. As it neared our sun, that hydrogen escaped, bubbling out without dragging dust along, explaining the thrust without a tail. It was a beautiful model, grounded in lab-tested physics, painting Oumuamua as a solid, layered object infused with its own propellant. Another theory saw it as a nitrogen ice shard, a piece of a Pluto-like world, its reflective surface and sublimating layers sculpting its shape and speed. Both ideas shared a truth. Oumuamua wasn't a hollow shell. Its interior was a geological marvel, a record of processes we'd never seen, forged in the cold of interstellar space. And then there was Avi Loeb's light sail hypothesis, the one that made hearts race and skeptics scoff. What if Oumuamua was an ultra-thin sheet, just millimeters thick, pushed by the pressure of sunlight? Its acceleration matched the math perfectly. A 1/r² relationship with the sun's distance. No gas or dust needed. Its tumbling could be the wobble of a sail catching cosmic winds. Its shape optimized to glide. Even this bold idea required substance, not a void, but a solid tensile structure able to withstand the stresses of its journey. Loeb's theory didn't prove alien origins, but it forced us to ask, why did a natural object behave so much like something designed? Why did every explanation, from ice to sails, demand a complexity we'd never seen before? As we pieced together these clues, Oumuamua became more than an object. It became a mirror. It reflected our curiosity, our fear of the unknown, our longing to find something beyond ourselves. Its passage was brief, a mere flicker in cosmic time, but it changed us. By 2025, new telescopes like the Vera C. Rubin Observatory were scanning the skies, hunting for other interstellar visitors. AI systems, free of human bias, were sifting through data, spotting patterns we'd missed. The universe was opening up, and Oumuamua was our first glimpse of what lay beyond. Whether it was a hydrogen iceberg, a nitrogen shard, a fusion-powered relic, or, dare we say it, a probe, it was a messenger. Its interior held clues to how matter forms, how worlds are born, how the cosmos weaves its endless tapestry.